Hello everyone, thank you all for being here. I'm very glad to have this opportunity to share this paper, BiLight, a smart bicycle monitoring and finding system for rider safety based on IoT technologies. I'm today's speaker, Dream Neutral. Nowadays, bike theft is pretty hard to prevent. It's often difficult to find stolen bike, and also if we call cops, they will only give you document to fill in and cannot help you further. So we designed a stealthy and smart device that can help us identify the rider, and we call it BiLight. So let's talk about the weakness of the existing anti-theft method. First of all, it can help you find your bike. And second, it can help you notify like 911. And also, it's pretty easy to break a lock. And it will take you some more times to find out that your bike is stolen. So our system has four features. The first one is acceleration data analysis, and rider identity recognition, emergency event notification, and anti-theft crowdsourcing. And our architecture includes the servers and our bike with the device on it. The device has a sensor, LED light, and a BiLight beacon module. So our device will capture acceleration data in real time, and when things happens like rider braking or bike receive impact, the device will notice and do whatever it needs to do. And also, if your bike is stolen, it will open the iBeacon module to send anonymous package to nearby smartphones and help us track our bike. So for acceleration data analysis, we use X-axis to do brake detection. If 5 out of 10 acceleration data is less than -50, we take it as a braking. And also we calculate the following angles for real-time bike status. So for status detection, we initialize the 3-axis data to the point where only Z-axis is subject to gravity. And when rotation happens, we use the following formula to calculate the angle. So for rider identity recognition, we use densely connected convolution network to train the rider's pattern. So and the owners will be immediately notified if the bike is stolen. And we use sense block as our core. So we change the number of the blocks to increase the extract features to get a better accuracy. So after comparing different number of layers, we found that 75 layers of BiLight is the most feasible number of our model, because we found that adding more layers doesn't help further improve our accuracy. And as you can see on the picture, BiLight's accuracy is much higher than the existing models like ResNet and DenseNet. So for anti-theft crowdsourcing, if the device detects that the bike is stolen, we will try to notify the owner. If we can notify, the device will open our iBeacon module and send anonymous signal to a nearby application user. And the surrounding user will receive the signal and send the locations to the servers, and we can help track our bike. So for a stolen bike location, there are three conditions according to the number of the nearby application user. So the first one is that if there's only one user, we will use the phone location as a bike location and have the lowest accuracy. And there happens to be two users, we'll calculate the possible locations with the position of the two phones, and you have a better accuracy than the first one. And the last one, if we receive three or more phone signal, we will use triangulation and have a best accuracy. So for true cover, there's also two possibilities. The first one is the circle attention to only 1 point and 2 points. We'll use different formula to calculate a better location of the bike. And if the server receives more than 3 notifications, we will use triangulation to estimate the location. And now we will show you the BiLight video we made and then do our demo. So for most important thing for a tail light is to turn on when you slow down. As you see when I pull the bike backward to simulate braking, the lights turns on. So our second feature is the emergency notification system. Our device will detect huge impact by the accelerator. And if I give my bike a force to simulate an accident, our phone will receive a warning message that shows that bike sensor received huge impact. And now if we hit the send text button, the emergency contact we set will receive a text message. So as you can see on the phone, the message includes a URL. And when the emergency contacts open it, it will show them where the accident happens. And they can choose to call 911 for us or come and help us. The next feature is our driver identity recognition. The onboard system has my accelerator data already, so if I start riding the bike for around 10 to 15 seconds, the device will detect whether a rider is me or not. And normally it won't show on the phone, but for demo purpose, I'll put the result on my phone. So as you can see on my phone, it says this is user dream riding, and that's me. I'm riding the bike. So now if we send the people that has no data on the device to ride the bike, and after around 10 to 15 seconds for the device to recognize the rider. And also to clarify, because we are now presenting has to acceleration the bike, we need a complete different data to ride on road. The bike won't recognize me if I ride on road now. And as you can see on the phone, your bike is ridden by other person. What we can do now is either add this person to our device or we can track down our bike's location. Now we present you our last feature, anti-thief association system. There are 3 phones in different locations to simulate our application user. Now if the thief tools this phone, the device will send a message that this is a stolen bike. And the application user will send the location to our servers to notice the owner. If the first user gets into the range of the device will notice, and the owner's phone will get a message. Now you can see on the phone, your bike is ridden by other person. Now we hit the open map button. So within a period of time, the owner will know the location of the bike and of course the thief. And now if the thief is still moving and getting to the range of another application user, as you can see on the map, the location change immediately. And then if the thief still moving and again pass by our third application user, as you can see on the phone, the location will change immediately. And this is the end of our present.